I mean, it was really bad.
Uh-oh, my husband being cool.
But I didn't. I was so proud of
All right,
myself when it
let's look at this. This is your Newton's Laws worksheet. And before we start on the problems, let's talk about units that go with variables. Okay, the unit for mass is what? The SI unit for mass is the kilogram. Good. And the SI unit for distance, meter. All right. The SI unit for time, seconds. Good. All right, now think about velocity. What's the SI unit for velocity? Velocity is distance over time. Meters per second. Good. Now let's consider acceleration. Acceleration is velocity over time. So the SI unit for acceleration is what? Meters per second squared. So we have meters per second, that's velocity, divided by time, that's where that second comes from. How about the SI unit for force?
Mass times acceleration.
It is mass times acceleration. It is the Newton. All right. Now, force is mass times acceleration. So mass is the kilogram, acceleration is meters per second squared. When we multiply mass times acceleration, we really multiply the units together, so we get something that is this, kilogram meters over second squared. To make it easy, we call that a Newton. And if we were to break down a Newton, we would break it down into kilogram meters over second squared. We call it the Newton with capital N to pay tribute to Isaac Newton. All right. Let's look at number 1. Calculate the newtons, or calculate the weight in newtons of a 2,000 kilogram car. What's the difference between mass and weight?
Weight is applied with gravity.
Weight is mass with gravity. So if I want the weight, then I'm taking gravity into account. What is acceleration due to gravity on Earth? 9.8 meters per second squared. Is it 1.96 in standard, maybe, possibly? All right. So here we have a 2,000 kilogram car. Uh-oh. That should be a 0. 2,000 kilograms. We're going to put 2,000 kilograms over 1. The equality you're going to use to convert this is on Earth, we have 1 kilogram is equal to 9.8 newtons. And all that is 1 kilogram multiplied by 9.8 meters per second squared gives us 9.8 newtons on Earth. So now we set up the conversion. And how am I going to set this up? Put what on the top?
Newton.
Good. 9.8 newtons per kilogram. Cancel out the kilograms. And it's 2,000 times 9.8. And we should get 19,600 newtons on example A. Example B. Calculate the acceleration of a 3,000 kilogram truck when the thrust of the engine is 300 newtons. What variables do we have in this problem?
Force and mass.
We have force, 300 newtons is force, and we have mass, 3,000 kilograms is mass. What are we looking for?
Acceleration.
What formula are we going to use? Newton's second law. Force equals mass times acceleration. Good. What variable are we looking for?
Acceleration.
So we've got to solve for acceleration. Before you plug in any numbers, make sure you solve for the variable that you're looking for. So how are we going to solve for acceleration?
Divide by n.
Divide out m. Whatever we do on one side of the equation, we have to do on the other side of the equation. So here I'm going to divide out m. Cancel m, and we see that acceleration is given by force divided by mass. Now we can plug in. When I plug in for force, I'm going to write the Newton in its subunits. So I'm going to write kilogram meters per second squared. And I'm doing this on purpose. Then I'm going to plug in 3,000 kilograms. You see anything that cancels there? Kilograms will cancel, which leaves me with the unit meters per second squared. 300 divided by 3,000 is going to be 0.1, and the unit is meters per second squared. What variable were we looking for? Acceleration. So we got the unit for acceleration. So I did that so you can see how a Newton can be converted into acceleration. Example C. Given the equation, acceleration equals force divided by mass, solve for force.
Where do we divide mass?
Right, we want to solve for F. That means get force all by itself. That means we have to get rid of mass. If it's in the denominator, then we're going to multiply by it to get rid of it. Whatever we do on one side of the equation, we have to do on the other side of the equation. So we've got to multiply by mass over here. Cancel out mass, and we just solve for Newton's second law. Force equals mass times acceleration.
Could you do acceleration times mass?
Yes, you could do it acceleration times mass. It's the same thing. Yep, doesn't matter the order of those variables. So we're going to solve for these variables all year. We're going to have more complicated problems where we solve for variables. So don't worry if you're not getting that yet. You'll get more practice at it. Let's look at the problems. Calculate in newtons the weight of a 0.2 kilogram Hot Wheel car. So on this one, you're going to use your conversion. 1 kilogram is 9.8 newtons on Earth. Number 2, calculate the acceleration of a 2,000 kilogram car when the thrust of the engine is 500 newtons. You have your mass, you have your force. You're going to solve for acceleration and then find acceleration. Turn the page over. On number 3, you're given acceleration equals force divided by mass. You're going to solve for mass. This is a little more difficult because mass is in the denominator. You're going to have to multiply by mass to get it up in the numerator and then divide out acceleration. So it's a two-step process here. Number 4, given the equality 1 kilogram equals 2.2 pounds, find your weight on Earth in kilograms. So first you use this equality and find your weight in kilograms. Then you're going to convert your weight to newtons using our 1 kilogram equals 9.8 newtons again. Number 5, very straightforward. Force equals mass times acceleration. You're looking for force. Here's your mass. Here's your acceleration. All right. This paper is due tomorrow. You'll probably have it done by the end of class.